So, what does a midpoint of a line segment mean? Midpoint is a point. When you say bisector, you are referring to a line. So midpoint must be a point, right? Let's say I have a line, a simple line that looks like this. A and B. This being 2 and this is 10. Where's the midpoint? Or rather, what are the coordinates of the midpoint?
6 and y.
I forgot to include this. Let's be 3. Okay, what are the coordinates of midpoint?
6, 3.
Of midpoint. We should spell it out. midpoint equals to, you are telling me it is 6, 3. 3, 6. No lah, cannot be 3, 6 lah. Okay, x coordinate first. So, let's start with the easy one, which is the 3 over here. Obviously, it must lie along the line, right? Which, in this case, the whole line is the graph of y equals to 3. This line over here has the equation y equals to 3. All the y coordinates are 3. That's why you get a horizontal line. That's why the gradient is 0. That's why there is no x. And the y-intercept must obviously be 3. And this is what it means by y equals to 3. So the y coordinate is standard 3. What about the x coordinate? Midpoint, midpoint must be in the middle, right? So what is in the middle of 2 and 10? We break it out into two equal parts. And you are telling me that it is 6. I hope you are not using trial and error. Are you able to tell me how to get 6?
10 minus 2, then you can answer the other.
Okay, so I've got one option. 10 minus 2 equals to 8, and then 8 divided by 2 equals to 4, and then 2 plus 4 equals to 6. Okay, this? That's an easier way. 10 plus 2 divided by 2. Why would that work? It looks like it works, right? 10 plus 2 divided by 2. Alternatively, we take 10 plus 2 divided by 2, we get 6. Why does this work? I heard the word already. It starts with A. Average. It is the average, isn't it? 10 and 2, what is the average? Must be in the middle. Understand? So, in order to find the midpoint, we are actually considering the average. Okay, what about a vertical line? Like this. Okay, so let's say this is point A, this is point B. Let us have this as 2, this being -1, and this is 9. What is the midpoint of AB? Okay, what is the x coordinate first? 2. What about the y coordinate? How do you get 4? 9 plus -1 divided by 2. So you get 2, 4. Then check your answer. Okay, let's say this is the midpoint. 4. There are 5 units over here. There are 5 units over here. 10. So it is literally the average. Literally the average. Regardless of x or y coordinate. Okay? Now let's generalize this to a line that is not vertical, not horizontal. So diagonal line. Let's say I've got a line like this. This is my point A. This is my point B. B coordinates. Let this be 10. Let this be 9, 1, and maybe 2. Okay. So 10, 9. 1, 2. Midpoint of AB equals to? Okay, come. What is the x coordinate for the midpoint? What do you have? 5.5. How do you get 5.5? Then plus 1 divided by 2. Okay, then what about y coordinate? And what do we have? Okay, that's it. Another example, now I will change my graph. Okay, what's the midpoint of AB right now? What's the midpoint of AB? Wait, I didn't give this, right? So let this be 2 lah. 2 and negative 3. Okay, so come, what's the x coordinate? 10 plus 2 over 2. Y coordinate? 4 plus negative 3. Okay, then divided by 2. And final answer? Can? So based on this, does the midpoint lie above or below the x-axis? Above. It is somewhere here. 6.5. Understand how this works? Do you need to do some examples for yourself? No need lah. Okay. Then let's move on lah. Oh, wait. There is one thing you need to know. Please take a look at work example 2. Page 160, work example number 2. Then you see that diagram over there? What is that quadrilateral? What's the name of that quadrilateral? Parallelogram. Okay. There is something you need to know about the diagonals of the parallelogram. Do you remember what you learned in your lower sec? Yeah. Can you remind me to take it later? What do you learn about the diagonals? Thank you. So diagonals like this lah. And another one. What's so special about this point? For a parallelogram, their diagonals will meet at the center. Okay, you're right. But my point is that this part and this part, they have the same length. Yes? So what can you tell me about the, let's call this point C. What can you tell me about point C with regard to AB? C is the midpoint of AB. What about DE? C is the midpoint of DE. Good. If I change this to a rhombus, does anything change? No. Rectangle? No. Square? No. Center of gravity. What about a kite? Remember what a kite is? Still doesn't change. So this is a kite. So we got change not? A, B, C, D. Diagonal. Okay, let's call this E. What can you tell me about the point E with regard to DB? Okay, this part, E is the midpoint of DB. What about AC? Obviously not lah. Okay, so you must know this. Next, parallel and perpendicular lines. Oh, we are moving on to 5.2 already. Still coordinate geometry. Okay, recap. What can you tell me about the gradients of two parallel lines? If this gradient equals to 2, what is this gradient? Okay, so half of 5.2 is finished already. Parallel lines. Okay? Yeah, really like that. Now I want to show you a diagram. This is found on page 163. Page 163, you look at the case 2. Do you see the case 2 diagram? This is what I have lah. Case 1 you finished already. Case 1 is just the parallel lines. Okay? Now case 2, you can close your textbook already. Then look at my screen, because this is very interesting. I've got 2 lines, they intersect with each other, right? Let's call the point of intersection P lah. Let's call this P. Then I've got line 1. We read this as line 1. Line 1 has an equation of y equals to m1x plus c1. What can you tell me about the value of m1? Anything that you can tell me about a gradient of m1? Why will m1 be negative? Okay, so m1 must be positive number. Okay, what can you tell me about c1? C1 is negative, right? Why? Because this is C1. Get it? Then I've got another line. The other line is called line number 2. Line 2 has an equation of y equals to m2x plus c2. What can you tell me about m2? It is negative. Good. What can you tell me about c2? Positive. Where is c2 in my graph? Okay. Alright so far? Do you remember the equation of a gradient? Formula for gradient? Equals to rise over run, which is also y2 minus y1 over x2 minus x1, yes? Okay. Let's consider this case. Line 1 and line 2 are perpendicular. Now this information given to you are line 1, line 2 are perpendicular. Where is the 90 degrees? At point P, right? Okay. Am I right to say that this is 90 degrees? Yes. And likewise, the 4 of them are all 90 degrees, yes? Okay, now I'm going to drop a perpendicular down. This term, drop a perpendicular, will be used in your syllabus. I drop a perpendicular down to the x-axis. Understand what this means? Okay, now I'm going to name a few more points. Let's call this point Q. This point is point S and point R. Yes? Yes, those who need to go, please go. Okay, the rest of you, focus. This is the exciting part. How many triangles do you see in this diagram? Actually, many triangles, right? Yeah, many triangles. Okay. How many similar triangles do you see? Oh, back to similarity again. Where? Okay, name me a pair of similar triangles.
RQ, C2.
R. Oh, okay. I only want the triangles, right, with these vertices. So don't give me C1, C2. Wow, too many options already. Okay, so let's try. You are suggesting that triangle PQS, is it? And R. What is the next one? Okay, so what do you want? PQS and RSP. PRS. Like that? PQS, PRS. Sure or not? No?
No.
Okay, then let's talk about why is this wrong. I give you a clue. Let's call this alpha. Okay? What must this be? In terms of alpha, what must that be? In terms of alpha. Okay, so how much is it? Simplify. 90 minus alpha. Okay? I don't want to write down, not a lot of space. If this is 90 minus alpha, then what must this be?
90 minus 90.
So what is it?
90 minus 90.
Yeah, it's alpha. Okay, so now, okay with this so far? No? These two are alpha, they're the same angles, right? Now you tell me whether the line in green is correct or wrong.
Wrong.
Why wrong? Naming. Okay, let's see. Does P correspond to P? Okay lah, P and P. Yes or no? What is at, okay, here you are trying to use the small triangle, right? This is the big triangle, right? Okay, in a small triangle, my angle P is, let's use colors, this green angle, which must be the same as this angle, right? Agree? Because definitely they are similar. I've got 90 degrees in both triangles. I've got alpha in both triangles. The third angle must be the same. I'm actually using the angle similarity test. So now, for the small triangle, where is the angle for P? For the small triangle, the angle for P is the green color one, yes? Yes? Then it must correspond to the same angle in my big triangle. What is that? R. Okay, now they correspond. Next angle, Q. What does it correspond to in the big triangle? P. And the last one must be S. Over here is our 90 degrees. It must also correspond to S. Agree? Agree with this so far?
Yes.
Can or not? Really, really, you must be able to see that these two are similar.
So alpha beta is actually the solution? Or just anyhow number?
You don't anyhow throwing your alpha beta into this topic, not related. Where got beta? You forgot, go and watch the video again. Okay, so now I think you will agree that these two triangles are similar. Okay? What is now the gradient? Gradient of L1 equals to what? What's the gradient of L1? No, C is the intercept. What's the gradient of L1? What do we say it was? It is on the screen already. What is? What? M1, right? That is the gradient of line 1. Okay, M1. Then we want to do some calculations. What is the formula for gradient again? Rise over run or y1 minus y2 over x1 minus x2 or the other way around. Which one do you think is more convenient to use in this case? Rise over run or y2 minus y1 over x2 minus x1? In this case, I'm sure more convenient. Because I don't have numbers, I don't have coordinates. Rise over run. Okay, tell me what's the rise? There are lines you can see, right? Will you agree with me that the rise is PS? Yes. Then what is the run? QS. Good. Since these two triangles are similar, and then I see a ratio over here, a ratio of sides, right? Can you find another ratio of sides that is the same? PS and SR. Why? Okay, PS and SR is O. Wait. Let's find out where this QS is. Where is QS? In this triangle, right? QS. Yes? Agree? Then I've got our PS over here, right? Okay, which one is in the denominator? QS, right? Which is the smaller triangle. This is the smaller. Yeah, you can draw another triangle, but I don't have enough space over here. This is the big triangle. Okay? So I've got my PS, which is the big triangle over the small triangle. Agree? Agree? Okay, now I want another ratio. There are more options that you can choose from. Okay, so give me some suggestions. What else can I have besides PS over QS that is equivalent to it? Yes, come. Let's try. RS over PS. Any more? Any more? PR over QR. Have I covered all the sides already? I believe so, because the triangle only got 3 sides. Now, let's talk about the gradient of L2. What is it equal to? M2. Okay, what is the value, or if you want to calculate M2, what is it going to be?
PS over QR.
PS over QR. Sure?
Yes, over SR.
Line number 2
QS.
PS, that's the rise over SR. But is the sign correct? Is it? Because PS is positive, right? It's a positive now. That's a length. PS is a length. It's positive. SR is also a length. It's positive, right? Positive divided by positive will give you positive. But we know that when you use rise over run, you must be very certain about how it slopes. So am I right to say that I must put in the negative now? All of you agree? Sloping down must be negative. Sloping up is positive. All okay so far? Now let's consider what happens when I take M1 times M2. Okay, now M1 I've got 3 options over here. 1, 2, and 3. M2 is this one. Okay, so I don't want to choose my M1 yet, but I'll write down my M2, which is negative PS over SR. What will you choose to put in for M1? 1, 2, or 3? 1, 2, or 3? Think. 2. Racy choose 2. What will you choose? Does it matter or does not matter? Okay, then who chose 1? Raise your hand. Who chose 2? Quite significant number of people choose 2. Number 3. So why are you all choosing 2? Can cancel? Then the rest who didn't raise our hand, do you know what they are talking about? So let's just see what happens when we put in their choice in. RS over PS. What happens now? What does this give us? PS and PS can cancel, right? Yes? What about RS and SR? Are they the same thing? SR and RS. Okay. SR and RS. Isn't it the same length? So can cancel. What am I left with? What's 0? What's the answer? Negative 1. Because it is sloping down. If I don't have a negative sign, then it will be sloping up, which is not correct in this diagram. It is sloping down. Okay? What is the whole point of this? Remember what was the first assumption or first rule that we had? L1 and L2 are perpendicular. So when L1 and L2 are perpendicular, what do you see is the conclusion about the product of the gradient? Where got positive 1? Yeah, this is the conclusion. When you have 2 lines that are perpendicular to each other, you multiply their gradients together, you will get a constant. And the constant is negative 1. Always. You see, did I give you any specific values for the gradient? I did not. Did I give you any specific values for the coordinates for these lines? I did not. These are all general statements that apply to a general case. And this general case only has one restriction, which is the lines are perpendicular. Get it? Okay, now your turn to tell me. If you didn't catch any of this, right, it's okay. Because some people prefer to simply memorize. So this is what we have. If 2 lines are perpendicular, the product of their gradients is negative 1. This is it. I am quite sure that after some time you will forget this proof, Then maybe when you're revising for your O levels in Sec 4, you just memorize this. One fine day you might be wondering why. Then just remember that I taught it before. Then you can go and watch the video. Yes? I recorded. Yes?
If you say bisect, is it perpendicular also?
Where got bisect?
No, if they say like the C1 bisect, no, the line 1 bisect line 2, right? It's also considered perpendicular, right?
A, B, C, D. This is bisecting. Do they look perpendicular?
No.
Then doesn't mean that lah. Next, your job is to tell me whether the line with the gradient M1 and M2 are perpendicular. Is L1 perpendicular to L2? Okay, so obvious. Here I got line 1 equals to line 1. Y equals to M1x plus C1. Then I've got line 2. Y equals to M2x plus C2. Okay? So, 2 and negative half, are they perpendicular? Yes or no? This is our M1, this is M2 lah. So they are perpendicular because 2 times negative half equals to negative 1. So perpendicular. Okay? Next, let's have 3 and negative 1/3. Perpendicular or not? Perpendicular, yes. Does it take a lot of effort to tell whether they are perpendicular? Okay, then how about 5 over 6 and 6 over 5? Perpendicular or not?
No.
Perpendicular or not?
No.
How about this?
Yes.
Now they are perpendicular. Yeah, so you get the idea lah. So that's all for our perpendicular lines and parallel lines. So similarly I want to go through certain concepts, not entire questions but certain concepts only. Now look at page 164, work example number 3. Part A, the word collinear. What does this mean? Okay, so read the question. So let's take a look at part A. If they are collinear, there are a few things that we can also tell. Okay, let's say if A, B, did they use AB? Okay, never mind. So if O, A, B are collinear, what can you tell me about the gradient of OA and gradient of AB? Fill in the blank. With either equal or not equal. Equal lah, must be equal, right? Not same line. What can you tell me about the gradient of OA and OB? OA and OB. Also equal lah, must be equal, because it's the same straight line. Does equal gradient imply they are collinear? Listen to the question again. Does equal gradient imply they are collinear? Yeah, it doesn't, right? Why? Parallel lines have equal gradient, but they are not collinear. So there are two things that you need to prove in order to say that points are collinear. Of course, the first one is that gradient is the same. Okay, so number 1, gradient OA equals to gradient OB, or you can say gradient OA equals to gradient AB. They are the same thing. Can so far? This is the first point. Second point.
Not parallel.
No, we want them to be parallel. If 3 points are on the same line, okay, let's draw this out. O A and B. For them to lie on the same line, the gradient of OA must be a gradient of OB. Or you can say that gradient of OA equals to gradient of AB. Yes?
Yes.
There is a second condition. That is, there must be a common point. Okay? Common point by itself doesn't mean they are collinear. Parallel lines by itself doesn't mean they are collinear. But when you have these two conditions together, then they are collinear. Who needs me to explain this? None. Okay. So if I choose to consider gradient of OA and gradient of OB, where is my common point? OA and OB, where is the common point? O is the common point. If I choose to consider OA and AB, where is my common point? A. Good.
So,
Yes?
but for the first one, right, the OA to OB, right, doesn't OB also pass through OA?
Yes, it does. Or you should say yes, OA passes through OB.
Yeah.
Yeah, okay then.
Then why is the common point not A?
Why is the common point not A? Because when we write it this way, okay, if I don't show you explicitly that they are on a same line, O, A, and B, they appear to be on a straight line, yes? I can find, it could very well have been this case. So you cannot say that OA lies on AB, on OB. Therefore, you cannot say that A is a common point in this case. Understand? But what is definite is that O is a common point. That's how you choose it. So for work example number 3, to prove that they are collinear, since they are collinear, we know that the gradient must be the same. So you can solve for K by yourself. Now let us do practice now 4. Question 2. Part 1, Part 2, and Part 3. You have 5 minutes for this. Okay, please stop work and help me check my work. Part 1. Midpoint. And check your presentation also. Midpoint, I've got my x coordinates to be 5 plus 1 over 2 and 1 plus 3 over 2, which is 3, 2. Correct? Okay, now part 2. So this is the coordinates for M. M equals to this. Okay, MC is perpendicular to AB. Gradient MC times gradient AB equals to -1. Correct? That's on the board, right? I put down the 2 more things that we have learned today already. So gradient of MC. This is the coordinates for M. Coordinates for C, we have 2, K. Then for A, 0, 1. B, we've got -1, -2. So let us find the gradient of MC. 2 minus K. Since I'm solving for K, I use K minus 2 over 2 minus 3. This is the gradient for MC. Agree? Yes? C is... Oh, thank you. I saw the wrong question. K -1. 1, 3. Yeah. For A, we've got 1, 3. For B, it's 5, 1. So for MC, gradient of MC -1 minus 2 divided by K minus 3. That's the gradient of MC. Is it correct now? Okay, now gradient of AB. 3 minus 1 over 1 minus 5. This must be equals to negative 1. So negative 3 over k minus 3. 2 over negative 4. So negative half. Equals to negative 1. Negative 3 over k minus 3 equals to 2. K minus 3 equals to negative 3 over 2. K equals to 3 minus 3 over 2, which is 3 over 2. Okay? So, Zachary, how come we couldn't find your mistake? Did you use the wrong coordinates? Did you use coordinates of question 1 or not? You sure? You look lah, did you use the coordinates from question 1? Instead of question 2? You go and find your mistake. Now, part 3. Find the length of MC. MC will be our square root of okay, you fill in the blanks yourself. And what was the answer given in the back of the textbook? Square root? 3 over 2 square root 5. Like that? Okay. Now I've got a point to make over here for part 3, yes? Your length is negative. Part 2 or part 3? Part 2 or part 3? You have a careless mistake somewhere. Go and find it. Okay, now part 3. The answer is 3 over 2 times square root 5. What kind of number is this? It is a surd. In A maths, your final answer, if it is a surd, you leave it in a surd. Do not round off to 3SF for A maths. Okay? Exactly. If it is E maths, your answer is a surd, you round off to 3SF. Okay, that means you want me to fill in the blanks over here lah. You put in a calculator, then it will give you a decimal, right? Yeah, that's what we do not want. It's going to be a surd. Okay, MC, the coordinates of M is 3, 2. And for C, we've got K negative 1. K is found to be 3 over 2. Negative 1. So the difference in the X coordinates, we square it. Add it to the difference in the Y coordinates, square it. And square root the entire thing. Difference in X coordinates, 3 minus 3 over 2 square. 2 minus negative 1 plus 1 square it. So here we have 3 over 2 square, which is 9 over 4 plus 9. Which is 36 plus 9, 45 over 4. Yes? I can take out 9 times 5 over 4. Correct? So I get 3 over 2 square root 5. Surds. We've done this before. Square root 9 over 4? Above. 3 over 2. This is the value of k lah. Yes. Okay, homework. Exercise 5B. Question 248.